Alright, so here we are with the 4-6 notes. We're talking about the value of E. So, before we get to E, we're going to talk about compound interest and how is it calculated. So basically, if you go in and get some sort of savings or something, you end up getting what is called interest. So interest is basically, thanks for giving us your money. We loaned it out to so-and-so, but we are going to give you some money back because you allowed us to use your money and you kept it here for us. So in that case, what happens is you put in what they call a principal amount. So P is your initial amount or your principal. So we'll do that. And then you take 1 and add it to the rate that it's going to be an interest at. And of course that rate is as a decimal. Then we have our K value, which is the number of times that the interest is compounded. So what happens is you put in your value, your principal amount, your initial amount, and then it goes up at a certain rate. They say, thank you for giving this money. We'll give you a rate of this. And every month we will give you that rate. So every month that you have your money in here, we'll give it to you. You could have it every year that they take the amount and give you some money back. You could have quarterly. That would mean 4 times a year. So there's kind of different words that go with this K value. And then T is usually time in years. After you put all of those pieces in, you get A, the amount after investment. So I've kind of mentioned these values already, but let's say that they say this is going to happen annually. So they're going to take this rate, they're going to compound it annually. That would mean that your K value is 1, because it's having 1 time a year. Semi-annually just means twice a year. Alright, so compounded semi-annually, that would be a 2 for K. Compounded quarterly is going to be a 4 quarters in a dollar. And then monthly is going to be 12. They might do daily as well, which would be 365. So there's kind of a lot of options for that. So first thing that we've got here is our first example. So apparently we're going to deposit $100. So that's going to be our initial amount P in a savings account that earns 6. Oh, that is the word earns, not years. 6%, so 0.06 is our R. Annually, interest compounded monthly, and so that means our K is 12. So kind of a lot in that sentence, and we're going to write a function that represents the balance after T years. So we know that A is going to need to be there. We also have the 1 plus a fraction, and then we're going to put that to the K times T. And so T is, of course, the variable as well. So A and T stay. They're like our X and our Y. But then we put in each of these pieces. So 100 goes here as our P. Our R is 0.06. Our K is 12, and then we also put 12 up here. Alright, so we're going to use that function to find the balance after 18 years. So that means that T is 18. And so we have an A, 100, 1 plus 0.06 over 12, and that's going to be to the 12 times 18. Alright, so thinking of the order of operations. Alright, we're going to go ahead and do parentheses first. So we've got some parentheses here, so I just want to simplify this. So if I rewrite it, I'm going to get 100 times a new number of 1 plus 0.06 over 12. So if you do that correctly, it's technically 0.06 divided by 12. That plus a 1 leaves us with 1.005. And that's still being raised to the 12 times 18. Then we would need to do our exponents. So of course first I want to rewrite this 12 times 18 so that it's actually just a digit. So we're 12 times 18, bringing that to the power of 216. And so then if we actually evaluate that exponent, we're going to end up with 100 times 1.005 to the 216, which is actually 2.9368. And so if we multiply that last piece out, we're going to end up with $293.68. So after 18 years of not touching that money, you have almost tripled the value in this account. So there you go. All right, and then our next piece here is saying, okay, well, what if we wanted to try to do our interest daily or every minute or every second? And so because of that, they actually have done this limit here that says, okay, well, as this number of times taken goes towards infinite, meaning trying to do it every second, every millisecond, we end up with this value here, which is 1 plus r over k to the kt, and again, while k is going to infinity. So we end up getting this e value. And e is actually a digit kind of like pi, never actually ends. So we have 2.718281828, and you'd think it repeats, but it doesn't. So on that note, we have an e value that allows us to take it what we call compounded continuously. All right, and so again, it's kind of the extended version of this, where k becomes like infinity. Okay, so going down here, our new formula still has a p, all right, still has an r and a t, but now we have our e as our base. So a is still going to be the amount after investment. P is going to be your initial amount, whatever it is that you're putting into the account. Your R is a rate as a decimal. And your T is time in years. So the E button is actually over by your division key. So if you go to the division key but you do second, there's a little E up here. So second division is going to get your E. And so if we do our example here with using that E, we're going to deposit $250. So again, that's our P in a savings account with an interest compounded continuously. So that means we're using A equals. All right, and then at a rate of 2.5%, so that means it's 0.025. All right, so putting that into our function, we know that A is going to equal our principal amount, which is $250, and then our E to the R, which is 0.025, and then the T. Now, of course, they want you to do a T of 5 in this case. So if we use our equation and plug in a 5, to solve this, again, PEMDAS, we're going to need to do parentheses. We don't have any, so if we do exponents, that means that E is going to be raised to the 0.025 times 5, which is 0.125. So A equals 250 E to the 0.125. So E to the 0.125 is 250 times 1.1331. And so our amount is going to be that times 250. So 283.29. So the value is $283.29 after 5 years invested at a rate of compounding continuously. Alright, so you're going to use both of these equations, the compounded continuously equation, and then the one that talks about compounded quarterly or monthly compounded interest equations. So that's your 4/6.